Hello, this is Dr. Kraus with another video on Intro to PLCs. In this video, we're going to talk about seal-in circuits and especially how they might be safer than latching and unlatching. Should throw out a disclaimer, these videos are for entertainment purposes only, and I'm not giving you legal advice on how to create safe automation systems. Okay, so the key questions that I want you to learn as a result of this video is: one, what is a seal-in circuit? And two, how is it different from latching and unlatching? So the main application is that you have some piece of automation equipment or something that you want to turn on, and you want to leave it on until it's time to turn it off. And so it would be very similar to a simple switch. That's going to lead us to our safety application. The problem with simply using a switch is, what if you were designing something for a manufacturing environment and it was supposed to run all the time, and then there was a power outage and it turned back on, power is restored by the electric company or whoever. Do you want your piece of equipment to then just start up when maybe you're not there, or who knows if that would be a safe situation? So what we want to do is have a way to turn something on and then turn it off, but also have it automatically turn off as a result of a power outage. Maybe this is helpful to some of you, maybe not, but this is analogous to 2-wire versus 3-wire relay control. So in a 2-wire relay control, you simply have a switch that turns on the input to the relay, and a relay is just a switch that allows a small signal to control, or a push button to control the larger signal, something like that. The problem being, if it's just a mechanical switch that turns the relay on, then if there's a power outage, the relay would still be on when power is restored, and that could potentially be dangerous. Whereas relays can be wired in such a way that you have a momentary push button that activates it, and it activates an electromagnetic coil that holds it in the on position, but lets it release if power is lost to the relay. So in the event of a power interruption, that electromagnetic coil would disengage and the relay would be off when power is restored, and that is potentially a safer situation. So we can imitate this 2-wire versus 3-wire relay control in ladder logic, and I want to illustrate that with an example. In this illustration or demo, rung 1 is our seal-in circuit, which is analogous to the 3-wire relay control, where we have out 0, kind of imitating the electromagnetic coil that gets energized, but then that coil is broken, or that seal is broken, if there's a power outage. And then rungs 2 and 3, using latch and unlatch, would mimic 2-wire relay control, but where the downside is it stays on in the event of a power outage. Let's look at those two things in more detail now. So rung 1 is our seal-in circuit, where in 0 would turn this thing on. It's essential that this be a momentary push button so that I energize this coil. And then out 0 is in charge of keeping the rung on. If in 0 were a toggle switch, then in the event of a power outage, it would automatically turn back on, which is what we're trying to avoid. So you would be defeating the seal-in logic. So we're saying in 0 is like a cycle start. In 01 would be a cycle stop. That just is the normal way to turn off this rung. It's considered good practice to have like a global reset button that undoes all your seals. And like I said, the main thing here is that we push in 0, we turn the whole thing on, and then if there's a power outage, when the power is restored, in 0 and out 0 would both be false, and so the overall rung would stay false. In comparison, if we have latch and unlatch, so now a push button at in 2 is going to latch it on using an OTL, and then a push button at in 3 is going to latch it off. The problem being and I'll try to demonstrate this in just a minute, once this is on, it may survive and remain on even after a power outage. I'm going to simulate that in a minute using just switching my PLC into program mode and back to run mode. But I did do a quick test where I actually interrupted the power to my PLC, and it takes several minutes, so I'm not going to do it in this video. But by the time I got everything restored, this did stay on after the power cycling. So that's probably not what you want to do. Let's now do a quick demo of this in the Studio 5000 software. Okay, so here's my quick demo on latch and unlatch versus seal-in. I've got rung 1 here, and if I press in 0, it turns on out 0, and then I've got this alternate path, and out 0 stays on. It could then be turned off by pressing in 1, which is an XIC, and now everything is off. Alternatively, if something else caused my reset condition, then that would also turn it off. So one button turns it off, another button turns it on. In rungs 2 and 3, I've got a latch on and a latch off. So I press that once and it stays on. I press that once and it stays off. But if they're both on, and this is the key point, if I then imitate a power cycle by turning my PLC to program and then back to remote, I also have to then set it back to remote run, or just flip it all the way up to the run condition. Note that the latch survived the power cycle and is still on, whereas the seal-in circuit went off as a result of the power cycle. So again, not trying to give you legal advice. I'm really not an expert in any of these things. But a seal-in circuit is probably going to have a much better chance of not unintentionally turning everything on when power is restored. And so I'm recommending to my students seal-in circuits over latch and unlatch. Let me know if you've got other questions. Thanks.